Hello everyone, welcome to Python and AI Engineering for .NET Developer series. If you have spent your career writing C# code and you are likely comfortable with like for each loop, link expressions, strongly typed collections, but when you jump into the Python for AI engineering, so writing C# style code is often considered an anti-pattern. So on an AI project, when you are constantly transforming list of messages, filtering API responses, deduplicating tokens, and parsing nested JSONs, so those that adds to all adds up all, right? So in this lesson I'll show you how Python's 4 core collection types, let's say list, dictionary, set and tuple, and we'll map them to exactly to their C# counterparts. Then also we'll show you how the list comprehension pattern that's super useful and extensively used in real world AI data processing. Okay. So let's see, right? So in the collection types in Python, we see there are 4 different types. Again, there is analogous C# equivalent also I put it here. So let's say first one is a list, which is a collection of items. So you can add, you can remove data from it, so it is mutable. It is ordered list. That means when you query the data from a list, it will always go in a first in first out format, and it's not a unique. That means we can have duplicate data within a list. Second type of collection is tuple, right? In the C# also we have something called value tuple or a new type called record. So where the data is immutable, that means once a tuple is created, we cannot add a new item to it or cannot remove an item from it. So data is again is an ordered data, and there can be duplicated data, right? So third type is dictionary, similar to C# dictionaries or a list of key value pair. Again, this is a mutable, that means we can add, remove data from it. Then it is ordered starting from 3.7. And is it a unique key? So the key in the dictionary must be a unique. Value can be duplicate, but key must be unique key, or else it will give error. The fourth type is the set, which is similar to the hash set. Again, this is mutable. We can add, remove the data, but data in a set is not ordered, but data in a set is unique. Okay, so we can identify, let's say, 2 different set of lists, and then when you convert to a set, all the duplicate data will get removed. So set is similar to list, but unique list of unique collection of item. Okay. So now there are these 4 different collection type. There are slight variation the way we define them. So first thing, when you define a list, we use square bracket. When you define a tuple, we use the moon bracket. When you define a set, we use curly braces. And when you define a dictionary, here also use curly braces, but within each item, it's a pair, key and value pair would be there. Okay. So again, these are 4 different types. So now let's directly jump to Visual Studio. We'll create certain example of all these different types. Then we'll look into how to read the data from this list or tuple or set or dictionary. How can you add the data, how can you add multiple data. So we'll see certain operation in each of these collection types. So let's first look into the first collection type, this list. Okay. So here let's say I have a list of objects, so it can be list of string or list of object, anything. List with specific, we need to ensure it's within the square brackets, and the other list of item comma separated, right? So now let's say how do we access individual items of the list. So we can access using the standard curly braces with the index. So 0 is the index. Now if I want to, this index also supports both the positive and negative one. So that means the -1 being the last one or 0 being the first one. Now if I have the length method on top of the list of item, it will give me the length of number of items that are there, right? So now let's run the command, and we see the first output of the basic test. Okay. So here you see first length is 4 and pre-response 0. I'm getting the first message out is the index 0, and response -1, I'll get the last message which is the index -1. Okay. Okay, now let's look into list slicing. So that means, let's say I want to get part of the data, I want to get only the second data, or I want to get second and the third data, or I want to get some other data, right? So list slicing usually go with the syntax. We have the data, let's say we have the list, and there are 3 different parameters. So first one is start index, okay, second one is end index, and third one is step, right? Now we need to ensure the end index is exclusive, right? So that means whenever it's put something, let's say responses 1:3, it will start from the index 1 up to the index 3. Index 3 itself is not included, right? So if I run this first slice, it should give us the index 1, which is the second item, and up to index 3, that means the index 2. So it should give us message 2 and message 3. Similarly, if we access any individual element, okay, so this is the list comprehension. We'll go to the comprehension at the end, but let's say we'll go to the third one. For the time being, let me remove the comprehension. Okay, so now let's see if I don't pass the first parameter, right? So if you don't pass, this is exactly same as if I pass a 0, right? So that means from the starting of the element up to index 2. Now similarly, if I provide the first one but don't provide the second one, so that means from the second index up to last element. Similarly, if we provide a data, let's say index is empty, for starting index and index is empty, we provide some value as a step. That means you start from the 0th index, then the next element it will be with 2 steps. That means it will give us 0 and second index. That means your first element and the third element with the step 2. By default, if I don't provide it, by default is step 1, but you can provide step 2, step 3, whatever is required, right? So now let's run the second stage and see the response. So it will be list slicing. Okay, so let's clear it and run. So now if you see it now here on the first slice, it should give me the first index, that is the second item, and up to the third index, that means third item, right? So if you see here, it will give you 1 and up to 1, up to first index, up to the third index, so it should give us 1 and 3, right? So now let's see, if I go with the responses 0 2, it should give us response message 1 and message 2, which is 0 up to second index. Similarly, if I go with 2 column, then up starting with the index 2, which is the third item, and up to the end, that is the fourth one. Similarly, if I go with no first index, no end index, only with the step, it will always start from the first index as for 0th index, which is our item 1, and end index would be at up to end, but it will go with every second item. That means it will go with the first one and the third one. So if you see here, first one and the third one. So that's how list type usually works. Now the last thing we need to look into is the list mutation. Comprehension we'll leave it to the last, after we go through all the list, all the control, all the collection types. So now let's look into list mutation. As I told before, list is mutable. That means we can add item, remove item, or extend the list. All the operations are possible because list allow data modification. That means we can add or remove items from the list. Okay. For that, we first thing we need to look into is something called append. Append in the C sharp, it's a kind of an add method, and list.add is similarly list.append in Python. Right? So here we can provide a new item, and whenever we add a new item, then it will become the length that will get added to the original item. Now before we go here, you see there is something called list.copy. It actually creates a shallow copy, not a deep copy. So that means only the list itself is copied. That means the data within the list are going to be the same. That means batch 0th item of the batch 1 and 0th item of the batch, the responses would be the same. If I update the item 0 of responses, it will also update the item 0 of the batch. But this particular list are different. That means if I add a new item to the batch, it will not automatically get added to the new item as a list, initial list. So the length of batch will return 5 because initially we have 4 element, and when you copy it has 4 element, we appended 1 element, but list of responses will still remain as 4. Okay. So let's see, come to this second part. If I go ahead and update the element of any of the data, so as I told you, list is mutable, but here list copy is just a shallow copy, right? That means internally both the list will refer to the same item. The pointer go to the same item in the memory, right? So that means if you update the text of the first element with updated text, if I go to the same element in batch 1, batch or response, it will have the updated text. Similarly, we have a command called pop, which actually remove the specific item based on the index. That means pop2 will remove the item with index 2. Now the remove item we can also print it. Last one, we see if there are more number of items are there, I want to add it. It's like a list. In C sharp we have add range method. Here in Python we call it the extend method. So after you do extend, then these two items will get added to the batch, and total length will be initial 4. Then you remove one item, sorry, add one item, remove one item, segment 4, and the two new item it will be 6. Now let's run this list mutation and we see the response. So let's run the program now. See, the first item is a length of batch, which is 5 because a new item got added, but that does not change the length of response, which remain 4. But when you update the item within the list, then it will be applicable to both. Really, when I remove the second index item, it will go to the item at the index 2, which is the ID 3. That item got removed. So now we added two new item here as a extend. So the total item number count will be 6. That's all pretty much for the first collection type, list. Now let's go to the second collection type, which is tuple. Right? So tuple is similar to the list, but here it's the braces would be the moon bracket, right? It will not be the square bracket. So what does it mean? The tuple is immutable. That means we cannot add element to a tuple, or we cannot remove element from a tuple, but we can other operation on the list like reading the data, slicing the data, all those things are possible. Okay. So now let's see, run the basic tuple test, which is just reading the data similar index wise. Okay. So Python, if this is 0 2 tuple, so we see the data, right? 3 hello goodbye, 3 is the length, hello is the first element, goodbye is the third element. Now let's go to the tuple slicing. Okay. Now if I see it here, tuple slicing is again same format, 3 parameter. The first parameter is the start index, second parameter is the end index up to, not inclusive, and the third parameter is optional, which is the step. So here it will take the second item and the third item, which is how are you and goodbye. Now similarly, if I go with uh, 0th index colon 2, or without specifying the first part of the slice parameter, it will take start with 0 up to 2. So it will be first and second item, right? And the first item is hello, second item is how are you. So it's here hello, how are you. Similarly, if I go with first in start index will specify, but end index will not specify. It will go up to the end of the list or end of the tuple. So here, if I see which is the second index is goodbye, and the end of the tuple, this itself is the end of the tuple, right? So it will only print goodbye as a tuple. Okay? That's all about the tuple, how to access the element of the tuple and how to do slicing on the tuple. Comprehension, again I'll consolidate all the comprehension, will come to the list. This is a pretty good feature of the Python programming language, comprehension, and it's being extensively used in AI programming, so we'll come to that later. Third one I want to discuss is about the set. Right now, set is similar to again list, but it's with a curly braces, right? List is square bracket, tuple is moon bracket, set is a curly braces. And what does the set means? It is something similar to the mathematical operation of the two set, and the way we need to read a data from a set would be similar to how do we read the data from list and tuple, but there are specific operations that are available on set only. So let's first run the basic test where you want to just read the data, and whenever I want to check whether particular element is there in a set or not there, or similar operation possible in list also, where you say the message 1 in message set, it will just say if message 1 is available, it will say true. Now one thing to note, set is always unique collection of the data. So that means if let's say in a set, if we have duplicate item, and if I just print the length, it will ignore all the duplicate item, right? So let's run the application first, and then we'll look into what are the responses, right? This is the 04. So Python 04 set. Okay. So we see length is 3. Here also length is 3. The duplicate item is removed. Then message 1 in message set, yes, it's there. So it will be true. Message 4 in message set, which is not there. So it will be false. So now let's go to the set operation, which is actually very interesting, right? So if you take two set of the data, we know from the standard mathematics there are operations like union, intersection, difference, and symmetric difference. So what do you mean by union? You will actually combine the data from two different set and provide a list of items. So let's see Python test again. We'll see the response from union. Now union, we see message 1, 2, 3, and another set we have 2, 3, 4. So union have all the data from both the messages. Duplicates will be removed because it's a set. So it will have 1, 2, 3, and 4. Okay. Then we have, let's say, message set and intersection of another set. Intersection will be only the item that are commonly found. For example, here message 2 and message 3. Now we have the difference. Difference is something, let's say, whichever item is there in message set 1 but is not there in message set 2, which is item 1, which is message 1. Now symmetric difference is kind of, it should take the item which are there in either of these particular two set, which is the message set and another set, but is not commonly found. This is or the other way we can look into is union minus intersection. So union is 1, 2, 3, 4, intersection is 2, 3, so it will be 1 and 4. Right? So this is a methods that are available: union, intersection, difference, and symmetric difference. Python provide also mathematical operation, right, which is similar in nature, the same result, but it's a different way of representation. For example, here the pipe means union, and mean intersection, minus means difference, and this caret means symmetric difference. So again, if I run it now, same set of data. Okay. So that's about the set operation. Now let's go to the last collection type, which is list. Sorry, a dictionary. Okay. Now to define a dictionary, it will always with a curly braces, but instead of a single item, it would be key and value. Right? As discussed before, the key must be unique. Value does not matter. Value can be unique or not unique. Now, how do you read each of the element in a particular dictionary? Again, using the keys. So dictionary, we don't follow the index-based read item, but dictionary, whenever I want to read as a specific value, I can just pass the key, then we'll get the particular value. Okay. Then either of this, right? You can use these square brackets and the key, or you can just say get and the key. Get at another operation. For example, let's say I'll say get, I'll pass one key, but we can also provide a default value if the key is not found. So in some cases, this is quite useful. Let's say I want to search for a key. If the key is not there, I want to fall back to a default value. So you can use this. Okay. So again, here also same method as you have seen before in tuple or in set, that you can say particular item in message dictionary if it is there. Again, in this case, it will only look into the key. That means if this particular key exists in this particular dictionary. Okay. So now let's go ahead and run it. So first run the basic test. 103 dictionary. Okay, so now I got the data here. For example, again, so let's say this particular key non-existing does not exist, so you got the default value. Now when I try to get sender key, value would be 1. Similarly others. Okay, so now let's look into how the conditions and loops are used in Python. Again, it's pretty similar to how do we see in our .NET programming. Standard if statement, if condition the value, and then here just think, remember, if we come from C# world, right, we have else if. Now those things in Python, it's called elif. So it's a no space, it's a elif, single one. So again, elif, let's say the condition, and at the end there will be else, final else, right? Similarly, let's go, if we go to a loop, we have, let's say, for loop standard, for item in list do something. If I don't want to use the index base, if we want to use the index base, you can say for index in range. In the range, you can specify the length of respective list, or one range 1 to 4 actually will create from 1 up to the 4 element, but you can just pass length of a list, it will create a range of all the item in that particular list. Now third is the while loop. Again, it's quite similar to how in C# we have a while condition and the statement to execute. Now if you want to break within the loop, again exactly similar to C#, we have two statements: break and continue. Break will exit the loop. Continue will skip next executions, but continue with the next iteration of the loop. Now let's go back to our VS Code and we'll look into the example. How do we use these conditions and the loops? Okay, so now let's look into the example for conditions. So here I've taken a list of dictionaries. Now you can understand, right? So list is the square bracket, and within each list we have one key value pairs, which is the dictionaries. So it's a list of dictionaries. Now on the first element that we have it here is a method which actually accepts individual item here, which is a dictionary. Then you try to get the finish reason using the key, and then if uses the if else condition, if the reason is something, and then return some value. For example, if reason is enter, return complete. If the reason is, let's say, max token, to return as truncated. Similarly, if it does not match any of these three, it will return as an unknown reason. Okay. So now whenever we want to look through this particular item, as I discussed before, there are several ways. The first thing is the index base, right? Let's say when we say for I means index in range and length of responses. Now range function, whenever specify and provide the length of the responses, it will create index from 0 till the length. So it will, let's say I have here 4 1 2 3 4 elements. So it will the length of responses range, it will actually return as 0 1 2 3. Okay. So then once you go to each of the individual index, we can again read the data from the list based on the index. So if I just print this particular value, okay, so then it will print the classification reason. For the reason, it will go to this particular method and it will pass the response. So ideally, once we print this one, it should actually print each of these particular reason, right? So let's run it and then we see the first one is all the reason, and then the last one would be unknown and the stop, which is from the first for loop. The second for loop we discuss is for responses, but for R. It means for item in list. This is for index in range. This is for item in list. This is something similar to C# where you have the for each loop, right? Now again, we can pass the item itself directly and get the result out. Okay. The third one, sometime we need to, okay, this is a preferred option in Python. We usually don't use this option, but sometimes it is necessary to have a index, right? So in that case, we can use for, again, index, comma, the object, and then we use a enumerator on top of a list, which will actually provide a index enumeration, and then we can actually get a collection of I is index and R is the actual element. So if we now see those values, then also you can see it below. So next, look into the list comprehension. So list comprehension is something similar. How do we write the link queue queries in C#? And but again, it's a much better and simpler way in Python. But let's say we want to look through a list of item, and based on certain condition, you want to get that particular item, or you want to get some updated value of the particular item, which is called transformation. Okay. The first is where condition, which is filter. Now second, whenever you do select x and then the arrow, the math lambda with x star x, which is actually transformation of the particular object. And finally, once you do complete everything, when you convert to list, it actually convert to a target list. Now if we go back here in Python, is something similar, but here is the first one that we see here. This is the transformation. Then we have the for, which is a keyword. X is the item. In the numbers is a list, which is here like numbers. And then if there is a condition, we have if any condition filters, right? So that means again, if the condition is optional, so we can say any let's say transformation. So this first section is transformation, right? For any transformation for an item in item list. Similarly, transformation for item in item list if any specific condition satisfied. Now let's look into some VS Code. We'll go to some of the examples in different collections. We see how the comprehension works there. Okay, so let's look into the comprehension. Again, we'll go back to the list where you have a list of objects. Okay, list, or you can say list of dictionaries. Now the first comprehension example what you see, right, is the transformation for R item in a list. So in a list, it will go through each of the item, and then it will take for each item, it will try to do some transformation. Here transformation, since it is a dictionary type and I'm reading the key of ID. So when I print this one, it will actually give us all the IDs, message 1, message 2, message 3 and message 4. Similarly, if we go to the second example, again we are talking about R token, which is transformation for R in responses, which is all of the tokens, but I'm using a condition if the token is greater than 0. That means if token is 0, if that will not be included. Now let's go to the third one. Again, similar to the second item, R text for R in responses, but I saying if the text is not none. So not none in the case, it is similar to the null, right? If the text is not null, then or not none, then that will be included. So now let's run this function, and then we see how the list comprehension result. Again, the first one IDs, second one tokens where token is greater than 0, and third one list of text where the text is not none. Now let's go back to tuple and then we see the examples there. Okay, so now let me enable tuple comprehension. Again, this behave exactly and the same way or list comprehension works, but here if I want to get out as a tuple, we have to provide a tuple and the bracket, or else this will return you a list. Okay, so so tuple bracket, then the internal syntax is same. Okay, so again if I want to get the data, okay, this is also on the interest way. If you want to convert to from a list to tuple and tuple to list, we can just use the list or tuple method, then we pass the internal object, it will try to convert to a list or convert to a tuple. Now let's run the tuple comprehension. So it will first one, it will read from the message tuple every value, okay, for R with no transformation is there, it's the same data. Then next one, again R for R, but where R is not none. So since it's everything is not none, it again print the same value. For example, let's say if I have an empty value, now if I run it, so it will also print the empty value. But if I have something called a none, and if I print now, you see on the second item, none is not included. Again, just remember, empty string is not equal to null string. Okay, so now let's look into dictionary. And in the dictionary, if we see, again, comprehension is slightly different than comprehension in list or tuple. So it's not, but not so different. Okay, so what will happen is here, again, we have to give the symbol as dictionary, and it's a key value for key value in a iteration or in a, you can say in a dictionary, right? Dictionary items. So it's again, since it's a combination of key value pair, so it will always, instead of R for R in list, it will be key value for key value in a iteratable item, right? And if condition is met, is exactly same. Now let's see what's happening here, right? On the first one, I have this part up to this, right? It's a transformation key, then it's a value. Again, instead of value, it's actually a, let me put this for easy. Okay, so this is for the value for key value in message dictionary dot items. So by default, when you look through a dictionary, it would be keys. So if you want to look through the key value pair, we need to call the items, right? Now here you see it's an inline if else condition for this particular item, which goes in, let's say value if condition satisfy, else we have this any other value. This kind of a ternary operator, but little bit different syntax. So it should actually give us all the key column. If value is a string, the value would be 2 upper, or else it will be normal value for key value in the item. Now similarly with a condition, right? For example, key value for key value in a message dictionary item, if the value is a string and if the user in value, right? So what does that mean? If you go back here, we have the value is a string, and if user in value, again it's a string, check whether this particular text is there within this string. So what it will return as the filter dictionary. If I go to the second response, it just look through all the item wherever the value is a string. So I think here all 4 value are string, and here value contain user. So it will print the user, only that item. For example, let's say here I'll put something hello user. Now if I run, here you will see that two things, okay, because both the value contains the user. So I think that brings us to end of today's discussion. So we looked into various different collection types, the conditional operator, we looked at the loops and the comprehension. So please spend some time looking into the comprehension, because this is really powerful and it makes the code much more readable. If you see a lot of AI programming where you write we have to look through a lot of different responses, different messages, or the file set, it's actually come in handy, and its number of lines will be very less, it will be more readable. So all the examples that we have seen today as part of this video would be available in my TechWebit blog. So a link would be in the description. Please visit that link to download the examples and practice. Okay, so that's all for today. In next lesson, we'll tackle error handling for the Python, and how do we, whenever we make a LLM API call and it fails, how should you do the error handling? Or let's say network timeouts or responses are not properly structured. So how do we handle different kinds of error, right? So yeah, so next session we'll look into error handling. Everything we covered today, including the scripts, the configuration, the extended documentation, is available right now on techwebfit.com. While you are there, check out our deep dives into various technical blogs like on enterprise security, design principle, or put your skill to the test with our develop focus quizzes. And if you're ready to master the intersection of the .NET and AI, subscribe to the channel, and I'll see you in the next video. Thank you.